Good day, Dr. Habibola. My name is He Zijian. Metric number is 294,169 from SQQM 2033 Intermediate Calculus Group B. My title of individual assignment is Partial Derivative of Relative Maximum and Minimum. Okay, what is partial derivative? Partial derivative is calculate the rate of the change of a function of several variables with respect to one of those variables while holding the other variable fixed and constant. In the other words, a partial derivative allows only one variable to change at the time and help us to analyze the surface of maximum and minimum point. The definition: function f(x,y) is depend on two variables which is x and y, where x and y are independent of each other. Also can say that the function f partially depend on x and y, so the derivative of f also can known as partial derivative of f. If a differentiate function f with respect to x, we can take the y as a constant. But if the if we differentiate f with respect to y, also we can take the x as a constant. Next, the relative minimum and maximum. Okay, first is a function f(x,y) has a relative minimum at the point AB if f(x,y) is bigger equal to f(ab) of all the point xy in some region around AB. Next, second is a function f(xy) has a relative maximum at the point AB if f(xy) is smaller and equal to f(ab) for all point xy in some region around AB. Critical point. The point AB is a critical point of f(xy) is provided one of the following. F is AB equal to 0 also is equivalent to say that fx equal to 0 and fy equal to 0. Second is fx AB point AB and fy point AB doesn't exist. Okay, after that find the critical point. We also need to do the classification of critical point. So we use second partial derivative. Okay, the formula of second partial derivative is d point AB equal to f x point AB times f y minus f xy squared. Okay, there are the four type conclusion of the second partial derivative. Number one is if d bigger than 0 and f(x) is bigger than 0, then there is a relative minimum at point AB. Second, if b bigger than 0 and f(x) is smaller than 0, then there is a relative maximum at point AB. Number three is if d is smaller than 0, then the point AB is a saddle point. Number four, if d is equal to 0, then the point AB maybe can relative minimum or relative maximum or a saddle point. Okay, let's see an example. Example 1. Find and classify all the critical point of all fx xy equal to 2x squared plus 2xy plus 2y squared minus 6x. First, we need to find the critical point from first order, then second order to classify the critical point. So first is we separate fxy to fx is equal to 4x plus 2y minus 6. Next, fy is equal to 2x plus 4y. So after separate fx, then we continue to do fxx. So differentiate 4x is equal to 4. So then next is fyy. Differentiate fy 4y fy equal to 4y, then we see that fyy equal to 4. From for fxy, we can see that 2xy, right? Then we differentiate 2xy is equal to 2. Next, we must find the critical point. So we just let the critical point equation is fy equal to 2x plus 4y equal to 0. Then fx is equal to 4x plus 2y minus 6 equal to 0. Then fx we let is first equation, then fy is taking to second equation. So we find the fy to find the y. So we factorize, then we find the y is negative 1 or 2 x. Then we substitute y equal to 1 or 2, negative 1 or 2, then into the first equation fx. Then we can get that x is equal to 2. Now, after we uh, differentiate, after we simultaneous all the critical point, then we get the finally get the critical point is 2 and negative 1 from the equation only has a one solution. So we get the critical point. So we need to do the second derivative to classify them with formula D. The formula D is equal to fx times fyy minus fxy. So we're letting the critical point 2 and negative 1 to above equation. Then we get the answer equation is 12. So since the D is positive equal to 12 and fx 2 and negative 1 is equal to 4, then it's also positive. So that is a relative minimum point at critical point, which is 2 and negative 1. Okay. In conclusion, know that the partial derivative depend on the specific problem or function being analyzed. So it provides all the information about how the function change with respect to one of each variable while keeping the another variable constant. Thank you.